Connecting an AI to your real tools gets sold as magic. You watch a demo where someone types a sentence and the assistant reads their files, sends a message, books a meeting, and updates a database on its own, and it looks like the future arrived. Then you try to build the same thing and you discover that the magic is mostly plumbing. Careful, slightly tedious plumbing, with real safety decisions baked into every connection. I have Claude wired into my files, my messaging, and a chunk of my own automations, and I want to walk through what that actually involves, because the model is genuinely the easy part and the wiring is the real work. Let me start with a single idea that makes all of this click, because once it lands, the whole thing stops feeling like magic. A tool, in this context, is just a function with a description the model can read. That is it. You have some code that does a thing, say, read a file from disk. You write a description of that code in a form the model understands. It says, here is a tool called readFile. It takes one input, which is a path, and it returns the contents of that file. Now when you talk to the model, it can see that this tool exists. And when your request needs it, the model does not run the code itself. It cannot. What it does is say, I would like to call readFile with this path. Your system runs the actual code, gets the result, and hands it back to the model. The model never touches your machine directly. It asks, you execute, you return the answer. That request and answer loop is the entire mechanism behind every impressive agent demo you have ever seen. So the model is just choosing which described function to ask for and with what inputs. The reframing matters because it tells you exactly where the work is and where the risk is. The work is in writing good tools and good descriptions. The risk is in what those tools are allowed to do. The model is the part that comes ready-made. You do not build the intelligence. You build the hands and you decide what the hands are allowed to touch. Now let me bring in MCP because it solves a real and annoying problem. MCP stands for Model Context Protocol, and the short version is that it is a standard way to expose tools to an AI. Before something like this existed, if you wanted your assistant to talk to your files, your messaging app, and your database, you wired each of those into each AI application separately, in whatever bespoke way that app demanded. 3 tools and 2 apps, and you have 6 little integrations to build and maintain. MCP flips that. You build each tool once as an MCP server, describing what it offers in the standard format, and any application that speaks MCP can use it. Wire the tool once, plug it into anything. That is the whole pitch, and in practice it is a genuine relief, because it means the messaging connector I built does not care which AI app is on the other end. It just exposes its tools and whatever client connects can use them. Let me make the request and answer loop even more concrete, because it is the part people find hardest to picture. Imagine I ask my assistant to find a file about a certain topic and tell me what is in it. The model cannot search my disk. What it can do is see that it has 2 tools, one that lists files and one that reads a file. So it says, internally, I would like to call the list files tool. My system runs the actual list files code on my machine and hands the model back the list. The model looks at the list, picks the one that matches, and says, now I would like to call read file with this path. My system runs the read, hands back the contents, and only then does the model summarize what it found and answer me. 3 tool calls, each one a request from the model and an answer from my system, with my machine doing every real action and the model doing only the deciding. That back and forth is every agent demo you have ever seen, slowed down enough to see the gears. So what does it actually look like to wire one of these up in the unglamorous reality? The first unglamorous part is the descriptions. A tool is only as good as the description the model reads. If you describe it vaguely, the model uses it wrong, or at the wrong time, or with the wrong inputs. I have had tools that failed not because the code was broken, but because the description was sloppy, so the model misunderstood what it was for. Writing a good tool description is a small craft. You spell out exactly what it does, exactly what inputs it needs, and in what shape, and when it should and should not be used. It feels like writing documentation because it basically is, except the reader is a model that will take you completely literally. The second unglamorous part is authentications. Every real tool that touches a real service needs credentials. Your messaging tool needs to be logged in. Your file tool needs access to the right folders. Your calendar tool needs a token. And those credentials have to live somewhere safe and get handed to the tool without being exposed to the model itself. The model should be able to say send this message. It should never see the password that lets the tool send it. So there is a whole layer of managing secrets, tokens, and logins that sits underneath every connection, and it is exactly as fiddly as it sounds. This is unglamorous work, but it is where a sloppy setup leaks credentials, so it matters. The third unglamorous part, and the most important, is scoping. This is the safety question, and it is where I spend the most care. Every tool you expose is a permission you are granting. A read-only tool that fetches a file is low risk. The worst case is the model reads something it should not have. A tool that deletes files, sends messages to other people, or spends money is a completely different category. When you give a model a tool that can take a destructive or irreversible action, you are trusting its judgment with real consequences. And models, however good, can misjudge. So I scope hard. I give a tool the narrowest power that still lets it do its job. A tool that needs to read one folder gets access to one folder, not the whole disk. A tool that summarizes messages does not also get the power to send them unless sending is genuinely the point. Oh man. And for the genuinely dangerous actions, I put the human in the loop. This is the confirmation step, and it is the single most valuable safety pattern I use for anything destructive or irreversible. The tool does not just do the thing when the model asks. It pauses and asks me to confirm first. The model can propose deleting these files, or sending this message, or making this change, and I get to look at it and approve before it actually happens. That one pattern turns a scary capability into a safe one. The model gets to be helpful and propose the action, and I keep the final say on anything that would be painful to undo. You do not have to choose between a useless assistant and a dangerous one. You put a confirmation gate in front of the few actions that actually warrant it. Let me be honest about the failure modes because they are real. The most common one is the model calling a tool at the wrong time, usually because the description was unclear or because the model misread the situation. That is annoying but usually harmless if your tools are scoped well, because the worst it can do is the limited thing that tool allows. The more serious failure mode is a tool that is too powerful, meeting a model that misjudges, and that is exactly the combination the scoping and confirmation patterns exist to prevent. There is also plain breakage. Tools talk to real services, and real services change, go down, rate limit you, or return errors. So every tool needs to handle failure gracefully and report it clearly rather than leaving the model guessing about whether the thing worked. Let me give a concrete sense of how I think about scoping levels. Because narrowest power that does the job is easy to say and harder to apply. I sort tools into three rough tiers. The first tier is read-only, tools that look at things but change nothing. Read a file, list messages, fetch a record. These are low risk. The worst case is the model sees something it should not, and I hand them out freely. The second tier is reversible writes, tools that change something but in a way I can undo. Save a draft, file something into a folder, write a note. These I grant with a little more care, but they are recoverable, so I do not lose sleep. The third tier is irreversible or external, tools that send a message to another person, delete something for good, spend money, or publish in public. Those I treat as dangerous by default. They either do not get exposed to the agent at all, or they get exposed behind the confirmation gate. Sorting every tool into one of those three tiers before wiring it up makes the safety decision concrete instead of vague. Citizens and masses is a small but important detail on credentials that bites people. The credential a tool uses should itself be scoped as tightly as the service allows. If a messaging tool only needs to read messages, do not log it in with an account that can also delete the whole history. If a storage tool needs one folder, give its credential access to one folder, not the entire drive. That way, even if something goes wrong, even if the model misuses the tool or the tool has a bug, the damage is bounded by what that narrow credential could ever do. Defense in depth, the boring security idea, applies here exactly. Scope the tool and also scope the credentials behind the tool. So a mistake at one layer is caught by the limits at the next. Here is the part that surprised me when I first built this stuff. Once the plumbing is in place, the experience genuinely is good. Being able to ask in plain language for something that touches several of my real tools and having it actually happen is a real step up from clicking through 5 apps myself. The payoff is real, but it only feels like magic from the outside. From the inside, it is a set of carefully described functions, a credential layer kept away from the model, tight scoping on what each tool can touch, and a confirmation gate in front of anything that could hurt. The intelligence came in the box. Everything that makes it safe and useful, I had to build. So if you are thinking about wiring an AI into your own tools, here is the honest order of work. The model is ready and waiting, that part is solved. Your job is to write clear tool descriptions, keep your credentials safe and out of the model's view, scope every tool to the least power it needs, and gate the dangerous actions behind your own confirmations. Do those 4 things and you get an assistant that is genuinely useful and that you can actually trust. Skip them and you get either a toy that does not work or a loaded gun pointed at your own data. The difference between those 2 outcomes is entirely in the plumbing, not the model. One last practical note from living with this about how many tools to wire up, because more is not better. It is tempting, once you understand how easy it is to add a tool, to give your assistant access to everything. Every service, every action, the full keyring. Resist it. Every tool you add is one more thing the model can pick wrong, one more permission to reason about, one more failure mode to handle when a service breaks. An assistant with a handful of well-chosen tools that it uses correctly is far more useful than one with 30 tools that it occasionally fumbles. So I add tools deliberately only when there is a real recurring need, and I am happy to keep the set small. The goal is not an assistant that can technically do anything. It is an assistant that reliably does the things I actually need, and reliability comes from a tight, well-understood set of tools, not a sprawling one. If you like AI shown the way it actually works in practice, real systems with the unglamorous parts and the honest trade-offs left in, that is what I do here. So subscribe and follow along. Thanks for watching, and I will see you in the next one.